Okay, so we're looking at how to solve rational equations. A rational equation is something where the variable we're solving for appears in the denominator of a fraction. So it's called rational because the variable is in the denominator. Um, and one way that we solve this is we do what is sometimes referred to as fraction busting. So I don't want x in the denominator. I can't solve for x if it's in the denominator. So I want x to be in the numerator. So if I'm solving this equation here, I have 4 divided by x plus 3 plus 5 over 6 equals 23 over 18. I don't want x in the denominator. So the opposite of dividing by x plus 3 would be multiplying by x plus 3. So I am going to multiply each of the terms by x plus 3. So really, we're multiplying both sides of the equation by x plus 3. And the x plus 3 is going to distribute to all the terms. So if I were to put parentheses around this and say I'm multiplying it by x plus 3, right? So if I was multiplying by x plus 3, then multiply both sides by x plus 3, and this x plus 3 distributes. Like it's two numbers, but this term x plus 3 can be distributed. So I have 4 times x plus 3 divided by x plus 3 plus 5 times x plus 3 over 6 plus 23 times x plus 3 over 18. And remember, when we multiply fractions, both of these x plus 3's all have a denominator of 1. So I just have to multiply the numerators. And we do this because now on this first term, I have x plus 3 on the top and the bottom. So I'm creating the number 1. That divides out to 1. And then I'm just left with 4. So I have 4 plus, and I can distribute here. So 5x plus 15, that's still divided by 6, plus, now equals, sorry, it should be equals 23x plus 69 over 18. Now I could technically solve it from here, dealing with the fractions at the end, so like split up the 6 and divide 5 by 6 and divide 15 by 6. But as long as I'm in the mood for not dealing with fractions, I might as well just not deal with fractions. So I know that 6 and 18, so 6 times 3 equals 18. So if I multiply everything by 18, just like I did when I multiplied by x plus 3, then I'm going to also get rid of that 6. So 18 times 4 is 72. And before I distribute here, I'm going to first recognize that 18 divided by 6, because order doesn't matter when you multiply and divide. So 18 divided by 6 is 3. So really I have 3 times 5x plus 15. 18 over 6 simplifies to 3 over 1. And then I'll distribute that 3, and I'll get 72 plus 15x plus 45. And on the other side, the 18 and the 18 divide out to 1. So I have 23x plus 69. And then from here, I solve my fraction problem. I don't have fractions. And when I'm solving, that's kind of a good thing. I like not having fractions. So I'm going to take a second here just to think about, well, what kind of equation am I left with? And I don't have x squared. I only have singular x's that are not being raised to an exponent. So this is now, we started with a rational equation. Now we have a linear equation. So linear equation is just any equation where x is not squared. So now we have a linear equation, and linear equations I can just solve by isolating x, right? So I solved my fraction problem. Now I just want to move terms around. So subtract 15x from both sides. You could collect the x's on the other side. I just wanted it to be positive. And I'll subtract 69 from both sides. And then the 72 plus 45 minus 69 comes out to 48. And 23x minus 15x is 8x. Then dividing by 8, and we get x equals 6. So problem number 2 here is, pretty similar looking, but now I have more x's in the denominator. But the way we solve it is functionally the same thing. I don't want to deal with fractions. I don't want x to be in the denominator. So I'm going to, so I see that I have x, 2x squared, and x squared. And just like on the last problem when I multiplied by 18, I recognize here that x times 2 would be like 2x squared is x times 2. So if I multiply by 2x squared, I'm also multiplying by x and x squared. So multiplying everything by 2x squared will eliminate all the denominators for me in one fell swoop. So I'm going to multiply both sides by 2x squared. So that looks like this. And it's going to distribute to every term, of course. So times 2x squared times 2x squared times 2x squared. So here I have 2x squared divided by x. So I have, that's like 2 times x divided by x. Well, one of those pairs of x's divides to 1, and I'm just left with 2x. Right? So this is going to be 2x. 2x squared divided by 2x squared is 1. And then 2x squared divided by x squared is 2. Now I have a very simple equation to solve. 2x equals 1, and x equals 1/2. Okay, moving on to the third one. This one is a little bit spicier. So I have x squared plus 3x, and x plus 3. And I can see x squared plus 3x is the same as x times x plus 3, which is very convenient. So if I multiply everything by x times x plus 3 on both sides, then I won't have any fractions left. So I'm going to do that. I have 2x minus 1 over, and I'm just going to write this as x times x plus 3 equals 1 over x plus 3. And then I'm multiplying by times x plus 3 on all of the terms. So in the first one, x divided by x goes to 1, and then I can distribute the 2 to the x plus 3, so I get 2x plus 6. On the second one, everything divides to 1, so I'm just left with minus 1. And on the other side of the equal sign, I have x plus 3 divided by x plus 3, so those divide to 1, and I'm just left with x. And now, once again, I have a pretty straightforward equation to solve. I can subtract x. So I have x plus 5 equals 0, and x equals negative 5. All right, so the last one is our spiciest example of all. Now here, one of my terms is not a fraction, and the other two fractions, x minus 2 and x plus 3, don't have any factors in common. So the only thing I can do here is just multiply. I need to multiply by all my denominators. Multiply by x minus 2 and x plus 3, and that's going to remove all the fractions. So 1 over x minus 2 plus 8 over x plus 3 equals 1, and we're multiplying by this to all of the terms. So multiplied by x minus 2 times x plus 3. And on the right side, so it's times 1, but I am going to have to expand that out. So first, x minus 2 divided by x minus 2, that divides out to 1. And then I'm just left with x plus 3. Here I have x plus 3 and x plus 3 divides to 1. So I have 8x minus 16. And then on the right side, I'm going to need to expand this out. So I now have, if I don't expand it out, I have an equation that looks like this. And there's just no real way to see what x is going to be. I can combine the terms on the left side, 9x minus 13. But there's no real way to see, if you're really good at guessing and checking, maybe you can guess the answers here. But your best bet here is just going to be, to when in doubt, expand. So I'm going to expand this multiplication on the right. So I have x minus 2 times x plus 3. And that gives me x squared minus 2x plus 3x minus 6. So I multiply this out and I have x squared, so 9x minus 13 equals x squared plus x minus 6. And now, so I recognize that I have a quadratic equation because x is squared and I have an x term. So I need to make one side 0. So most of the terms are on the right side already, so I'm just going to subtract 9x and add 13. And this gives me 0 equals x squared plus 8x plus 7. Oh, minus 8x plus 7. Yeah, x minus 9x. And then here, so this looks like an equation I can factor. I need two numbers with a product of 7 and a sum negative 8. Only two numbers multiply to 7, 1 and 7. And conveniently, negative 1 and negative 7 makes negative 8. So I have x minus 1 times x minus 7 equals 0. So then x equals 1 and x equals 7.